All right, so last lecture I was talking about buffer overflows. And buffer overflows are a bug where you have some coding mistake in your code that can cause a region of memory, a buffer, to be written past. Like the code could write past the end of the object in memory, trashing something else in memory. And I wanted to talk to you a little bit about how these things are exploited and some of the history of how they're exploited. So probably the earliest prominent exploit of a buffer overrun bug dates all the way back to 1988, when the internet worm spread across. I mean, the internet was really tiny then, but spread across, basically shut down the whole internet. And there was, front page headline in the New York Times was, the internet shut down by this worm. Sys administrators had a hard time contacting each other because they knew other people at other institutions by email, and then they're like, oh, crud, I don't have their phone number. And what happened was a student had put together a proof of concept, a concept of a worm that would spread from machine to machine, attack a machine, infect it, and then start attacking other machines from there on, and was testing it on their local network to kind of show off the risk of this thing that had never been seen before. Only it escaped and made it out to the external internet and started infecting machines and propagating like crazy. And then there was also some code in there that the student had put to cause it to automatically shut down so that it wouldn't go too crazy. But that code had a bug, so it just went crazy. So think of like a oh crud moment where you write your code and you realize you've just taken down the internet. And that code exploited a bunch of bugs. But it had multiple different attacks. But one of them was a buffer overflow. There was a network service that had a buffer, and the code didn't check lengths, and so it would be glad to write past the end of the buffer. And stored not long after to memory was a program, the path to a program that this, like a executable, that this server would later execute. And so the attack was you write a long string past the end of the buffer, overwrite the path to the executable, and then later when that executable was invoked, now it's running some other code. Okay, so that was kind of the earliest buffer overrun exploit. And at the time, people thought, oh, okay, you probably don't want to have this kind of bug in your code, but most of the time it's not that big a deal because you only get really hosed if after your buffer there's something really sensitive like a path to an executable that you're going to use. And how often does that happen? Come on. So not that big a deal. Then in somewhere around 1996, there was this article published by a hacker, published this article, Smashing the Stack for Profit and Fun by Aleph Knott, I guess. And that was part of your readings, and you read that. And what that pointed out was, no, actually it's worse than you knew. It's worse than we previously thought. If you have that bug in your code and the buffer is allocated in the stack, it doesn't matter what's after it. You're probably hosed. So let me talk you through how that exploit worked.